Okay, again, today we're going to be working with algebraic identities. I call them specials. And one of the clues that you might be dealing with a special is that it has only two terms. There are three different specials we're going to talk about today. It's patterns on how to factor without doing the trial and error, okay? And so one of the ways that you are going to be able to recognize that your quadratic might be a special is if it has two terms, okay? That's our first clue. Then you're going to have three different specials to choose from. One of them is called the sum of two cubes. And if you'll remember, cubes is the exponent of 3. There's one called the difference of two cubes. Cubes means exponent of 3. And the third one is called the difference. I think these are listed in the other way on your paper, but it doesn't matter. Difference of two squares. And squares is the exponent of 2, okay? So, and also this word is important. These are our three specials that we're going to deal with. Difference means subtract. Subtract. Sum means add. Now this gives you the clues of what this might be and if it might be a special. So what we're going to do is when we come across this on our paper and we say, it only has two terms, so it could be a special. Let's check it out. So the first thing you're going to look at is a minus, okay? So you look over at your specials and you say, well, I've got a couple of them that deal with minus. It's definitely not that one. But I have two of them that deal with minus, so that's good. Your next clue is going to be right here. And so it can't be cubes because cubes has an exponent of 3 and 3. This one could be it. Could be it. Now, the way you check to make sure that it definitely is if you can find the square root of this term and if you can find the square root of this term. The square root of d squared is d. Now, I highly suggest you actually write the square root up there. And the reason is you will be using these circled answers in your factoring, okay? So you look here and you say, yeah, I could find the square root of this. And then you look here and say, oh, yeah, I can find the square root of that. It's 3. So on your paper, it tells you how to factor this without thinking, actually. It says then what you do is just take 2 parentheses. You put these in the first parentheses, put these in the second parentheses. So I have D and 3, D and 3. And the only difference in the parentheses is one of them is plus and one of them is minus. And it does not matter which one is which. This is how you factor the difference of two squares. Let me have that just a minute. I want to show you. So the way you read this now, here's the difference of two squares. This right here is the pattern that you're going to look for. You're going to look and make sure that there is a minus. You're going to make sure that you can find the square root of both of these pieces and put them in a circle. If all of this stuff is true, then this is how you factor it. You take whatever the first square root was and put them first. Whatever the second square root is, you put them second, and you have a plus and a minus. Doesn't matter which was which. So let's look down here at the example. And it says, I was given this problem. And I said, ooh, it has two terms. It has a minus in it. If I can find the square root of both of these pieces, it fits my example perfectly. So I could find the square root of x squared. I could find the square root of 9. These circled numbers up here are the ones that I put in the parentheses. X and 3, X and 3, X and 3, X and 3. And then all I need is plus and minus. Is that explanation sort of okay? Mary?
Yeah, a little bit.
Okay, we'll do some more, okay? Doris?
Yeah, it's okay.
Okay, let's do some more examples. Now let's look at number 1. I'm going to skip to one that might look scary, and it's just the first time you've seen it. There we go. Okay. 81 minus x squared y squared. Okay, so although this has a bunch of stuff, this is just one term. This is just one term. So I have two terms. And if I look at that, I think, could be a special. Maybe it's a special. And so you begin to look for clues in here. And you say, oh, I'm finding some squared. So let's see if it's the difference. Difference means subtract. I have to have a subtract. There is not a plus with squares. Okay, so only the minus with two squares. Okay, so it does have a minus. Let's see if I can find the square root of both of these. So the square root of 81 is 9. Now this one might look scary, but it's not. Square root of x is x, square root of y is y. So our square root of this whole term is xy. So it has a difference. It has two terms and they're squares. I'm able to find the square root. So I follow the pattern called difference of two squares. I know I'm going to have two parentheses, and the difference of two squares says put the first one in here, put the second one in here, and I can make them plus and minus. Doesn't matter which sign goes in which one because they're exactly the same. And this is how you factor the difference of two squares. Is it helping? A little bit better?
Yeah.
Tiny bit. And of course, we're going to go straight to number 5 because it has a fraction. You guys remember to speak up, remote students. I noticed the first time I watched one of my videos all the way through, and I noticed that my remote people are answering some questions, but it's not loud enough for me to hear. And so I'm not saying good or acknowledging that you guys are telling me something. So be sure and speak up. And if I don't acknowledge you, then scream at me. Just don't be mean. Okay? It'll make me cry if you're mean to me. Okay. Okay, let's do number 5 because it involves a fraction and we don't want you to be scared of fractions. And so this one is m squared over n squared minus 36. I'm going to check. Sandra thought she might come in. All right. Okay, and then when you come on a problem like this, you say, oh, two terms. Okay, it could be a special. I need to check. Start to look for clues. And one of our clues is the minus. So we're going to use one of the differences. And then our next clue is, oh, squareds, not cubes. So I need the difference of two squares. Now, the last thing I need to check before I know for sure is if I can get the square root of the first term and the square root of the second term. This one is the one that might be scary, but it's really not. The square root of m squared is m. The square root of n squared is n. So this is the square root of that fraction. That easy. You see? Yes. And the square root of 36 is 6. Now remember, please write these and circle them because these are the things that are in your factored answer. Nothing from here are roots that we put in the parentheses. So it's important to circle this up here for your brain. It helps it untie a little bit. So your difference of two squares, if you look on your reference sheet, says I put first and second here. That's first and second. And I put first and second here. So I've got m over n and 6, m over n and 6. And then however you want to put your plus and minus, they have to have opposite signs. And this is your factoring of the difference of two squares. Is it getting a little bit better? I hope.
Yes.
Everybody's kind of quiet. I want to do, well, I was thinking we might be taking the greatest common factor out, but I think we're just going to do identities today. How about if we look at, I'm going to go to the second page, SP2, and let's do number 2 there. Then we'll move on to a different type. This is on, at the top of the page, it says ES2. I'm right here. See at the top, it says ES2, and I'm going to do number 2. And if you numbered your pages, it's also number 2. So 2, 2, 2, C squared minus 1 over A squared. Okay, again, fractions, but you don't have to be scared of them. Again, let's go through the whole thought process. First time you see this problem, you say 2 terms. Let's investigate specials. The minus tells us we will only use the ones that have the minus word in them, difference. So this is not an option. Okay, difference of 2 squares or difference of 2 cubes. So you look at your next clue, which is the exponent. We're dealing with squares, not cubes. So it looks like it might be this one. Our last test is if we can find the square root of this and the square root of that. If you can't, then this can't be done by this pattern. So the square root of c squared is c. The square root of 1 over a squared, we found out that all you have to do is find the square root of this. Square root of 1 is 1. The square root of a squared is a. So we were able to find the square root and the square root. If all of those things work, then it matches our pattern and we factor like this. The first and second go here. First and second go here. Oops, 8, not 8, A. And this is the factored form for the difference of 2 squares. Better? It's funny to look at the sweat just right on the board. Okay, that should be enough examples until you learn to struggle through some of them yourself. But that's what I do. And then we're going to look at some different types. We'll go through the same thought process, which is cool. You know, we don't have new thought processes. So let's do this one. Okay, let's say that you came across this one. So our thought process is, two terms, right? So could be a special. I've got to do some investigation. So the first thing I look at is its difference. So I can only use these. We'll get to some sooner or later. But since it has a minus, it cannot be this one. So it could be one of these two, and then we begin to look for clues. And what, Brandy?
That's the second one.
Yes,
Difference of 2 cubes.
because of the 3, right? So the minus is the difference. And then we look at the cube. That's a big clue to us. Now, the last step is we have to check and see if we can find the cubed root of this and the cubed root of this. This, sometimes if you don't have it memorized, I use a calculator for this. And if you need to know how to find the cubed root on your calculator, I'll help you. So the cubed root of x cubed is x. Those are usually the pretty easy ones. And if you use your calculator or have it memorized, the cubed root of 125 is 5, because 5 times 5 times 5. It has to be the number times itself 3 times now. Or you can do it by hand. Remember this? 25 times 5 and 5 times 5. Right? And so we're going to see what teenagers get to go out of the house. And so mom says, because I need the cubed root, I need groups of 3 before you can go out of the house. So the 5s say, ooh, look, 3 5s. That's a group of 5s. Go back to factoring or simplifying radicals. There's a YouTube on that. There are 3 5s, and that means this group can go outside of the house, and there's nobody left to stay in the house. And so again, the cubed root of 125 is 5. That's how I got it. You can either use the prime factor tree, or you can use your calculator, or some of these smaller ones you can just memorize. Okay, so back to our pattern. We said there's 2 things, so it could be a special. We saw the minus, so we know it's one of the differences, and we saw the cubed. So it could be this one, difference of 2 cubes. And the only way we're sure is if we can find the cubed root of this one and the cubed root of this one. So that's where we are now. So if you look at your reference paper, it tells you exactly how to factor this without thinking. Follow the pattern. The pattern has a short parentheses and a long parentheses on your reference sheet. Now in the small parentheses, it says, take your first one and your second one and put a minus in it. This is what the pattern shows. Now here, you have to pay a little closer attention. It says, take the first one and square it. Then it has a plus in the pattern. I hope you're looking at the pattern. And then the second term in this long parenthesis says you need to multiply the first and second together. 5x. And then a plus sign, because that's what the pattern says. And then back here it says take the second one and square it. And you don't have to go any further. You just followed the pattern, and this is factoring the difference of 2 cubes. I don't know if this will help or confuse you more, but your reference sheet calls this first one A and the second one B. So the pattern that they showed you is you take the first one minus the second one. That I call this first and second, because if you call it A and B, it kind of messes you up. And then it says, take the first one and square it. Then it says, take the first one and multiply it by the second, which is what we just did. And then the last thing it says, go find the second number, which is B, and square it. This is the pattern they show you. This is how we followed the pattern. Am I confusing you or is it better? Can't tell. Doris?
It's better.
Say it one more time.
It's better.
Yeah, better?
Yes.
Okay. Mary? I've been missing you.
It's a
Mhm.
little confused to me. I don't know.
Are you still looking at it going, oh my gosh?
Yeah.
Okay. Okay. It will come.
Okay.
I don't know. I want to encourage you because it really will. After you see and you have to deal with some on your own,
Okay.
it will. But I'll do some more examples, okay? Because this is all. These three, that's all we're doing today. So let me give you this one. Okay, now I'm on page 3 if you follow along, and I will do number 3. So it says Q cubed plus 1 over R cubed. Okay, the thought process again, if I continue to tell you, maybe it'll stick in your head that you always need to go through this thought process, whether you say it out loud or not. Okay, the first thing you do is say, two terms might be a special. So I'm going to look at the possibilities. I look at the sign and it says plus. Well, out of our 3 specials, the only one that says plus is the sum. Sum means plus. So if it's any of these, it's going to be this one. Okay. And we check and see, is it for sure cubes that we're talking about? Because this is the only possibility. And sure enough, we are dealing with cubes. So we're still in the game. And then the last thing I have to do is see if I can find the cubed root of each of these. The cubed root of Q cubed is Q. And the cubed root of this, cubed root of 1 is 1. The cubed root of R cubed is R. So sure enough, I was able to find the cubed root of this and the cubed root of that has a plus. So I'm going to use this one. Now, I'm going to write the pattern down for you first. On your reference sheet, it says, if you have A cubed plus B cubed, if you've done all your tests and it fits this pattern, then this is how you factor it. You have a short parentheses and a long parentheses. This was A, and this is B. So what they show you in the pattern is A plus B, A squared minus AB plus B squared. So this is the pattern on your reference sheet. So we're going to follow this pattern to work out our factoring. Now, the A and the B are the first number, second number. First number, second number, okay? So right here, we're going to factor this way. First number, Q, has a plus sign. Second number, 1 over R. First number squared. Here's first number, Q squared minus, multiply first number and second number. Now, in this case, I'm going to take you over to a piece of scrap paper. It says to multiply these two together. It's not hard, but it's going to look rude to you. It says to multiply Q times 1 over R, right? It says to multiply first and second number. Well, when you multiply this, since you have a fraction here, let's make this a fraction. So the way you multiply fractions is to multiply the top, Q times 1 is Q, and multiply the bottom. 1 times R is R. And so on the answer sheet where they get the Q over R is when they multiplied the first number times the second number. So I have Q over R because I multiplied the first number times the second number. Here I am right here. Plus, then it says take the second number, B, take the second number and square it. What's 1 squared? 1. What's a second? What's this squared? R squared is R squared. This is as difficult as this gets. No, nothing harder. And seeing these patterns for the first time and having to use them, I understand. So when you start on these worksheets, you may want to go back and slow down the YouTube and look at it again, but I'll do another one. Let me see if I can find something that'll mess you up. So we make sure that everybody's okay. Let's go to the 4th page. Yeah, let's go to the 4th page, number 1. I'll show you the page in just a minute. Now, this is something that you'll probably want to do very slowly and talk to yourself. This page that I'm on says ES2. I'm going to be doing number 1. It says algebraic identities. Number 1. S cubed plus 1 over S cubed. Okay. And the instructions tell you to factor. They use a word called factorize. I had never seen that word until these worksheets. It just means to completely factor what you have here. Up until now, we've had 3 terms, but this is only 2 terms, and that's our clue that we might have a special. Now we're going to test it and find out what special, if any. Plus, out of our 3 that we're choosing from, there's only 1 that has a plus. So if it's a special, it has to be this one because of the plus sign. So our test is to find the cubed root of each piece. The cubed root of this is S. The cubed root of this, you have to find the cubed root of the top and the cubed root of the bottom. So I found the cubed root of this is S. The cubed root of this is 1 over S. So it fits all the qualifications to fit that pattern. Get that reference paper in front of you and look at the pattern, how to factor the sum of 2 cubes. It says we're going to have a short and a long parentheses. In the short parentheses, remember we're going to use the circled numbers, not anything down here, the circled numbers. So it says to put the first and the second number in this short parentheses. So I have S plus 1 over S. And that's all that goes in the front one. This back long parenthesis says the first thing you put in here is take your first number and square it. Then you have a minus. Be careful of these signs, they're different. So minus. Then the second term right here says to multiply the first and second together. So let's go over here and we're going to multiply the S times 1 over S.
S over S.
I'm sorry?
S over S.
Yes, yes. This will become a fraction so that we can multiply fractions. You multiply the top and the bottom. And guess what? Anything over itself is equal to 1. So when you look on the answer sheet, it's actually going to have the number 1 here, because when you multiply those together, you get 1. And then you have a plus sign. And then it says take the second number and square it. Here's the second number. If we're going to square this, we have to square the top, square the bottom. So I have 1 squared is 1. S squared is S squared. The main reason that I've got this one is because when you see this on the answer sheet, it might mess you up.
Yeah, I got the answer right except for the 1 because I put the S over the S.
And anything over itself is just 1, and that would have confused you when you looked at the answer. But you were correct in everything you did. What do y'all think?
Why did we not do that in the previous one?
Because these numbers weren't the same. It was like a P and something else. It wasn't another P. That's the difference.
Okay.
Good question. Do you think you have enough information now to hang yourself? Mary, do you think you have enough that maybe you can start through this? Maybe?
Yes.
Because I will do some more examples. That's the reason I'm asking.
No, it's fine. For me, it's fine. Yeah, I understand a little bit more.
I heard you talking and not one word. Did I understand? Say it again.
I understand a little bit more. Yeah.
Okay, you understand it a little bit more, and so you're ready to try the worksheets?
Yes, I think.
Okay, and you know I'm here by text or by phone, or you can stay on the Zoom. Okay?
Okay.
Doris? Doris, are you okay?
Yes, ma'am, I'm okay.
Okay, so you're ready to try the worksheets?
I'm ready.
Okay. Well, I'm finished with the recording for today. Those of you that want to stay on the Zoom, feel free.